In this video, let's solve a maxima-minima problem that involves differential calculus. Now, we have to find the greatest volume possible for a closed cylindrical tank to be made from 115 square meters of metal plate. And so let's draw our figure. Now, let's label this as the height. And then this will be the radius. Now, the equation of the volume is the cross-sectional area of this one multiplied by the height. The cross-sectional area of the circle is pi r squared. And then let's multiply that by the height. So this will be the equation of our volume. And so let's differentiate this function. But we need to get h in terms of r so that we will only have one variable to differentiate. Now, this is our constraint. The surface area of the metal plate should be 115 square meters. Now, the formula for the surface area is simply the circumference multiplied by the height. Because ito yung surface area, yung total area ng surfaces. And since closed yung cylindrical tank natin, this will be included sa surface area. Saka ito. And so our surface area will be the circumference, which is 2 pi r. That's essentially the length of this line. And since this has a height, let's multiply that by h. And then plus these two. Because again, our tank is closed. So we will add two areas of a circle. So dalawang pi r squared. Now we need to express h in terms of r. And so let's isolate this one. Again, our a is 115. So let's substitute that value. And then let's move this to the left. So that will be 2 pi r squared. And that's equal to 2 pi r h. And so to isolate h, let's divide both sides by 2 pi r. And so these will cancel. So our h will be 115 over 2 pi r minus 2 pi r squared divided by 2 pi r will become r. Kasi magka-cancel to. So this will be the h that we will use sa equation dito. And so our equation for the volume will be pi r squared multiplied by 115 over 2 pi r minus r. And so now, distribute natin to. And so our equation of the volume will become pi r squared times 115 over 2 pi r minus pi r squared times r will become pi r cubed. Now this will cancel, itong pi. And then yung r dito, magka-cancel din. Isa na lang yung matitira sa taas. And so our v will be r times 115 over 2 minus pi r cubed. Now, let's differentiate with respect to r so that we will be able to obtain the radius that will provide us with a maximum volume. We need to differentiate the volume equation with respect to r and set the derivative to 0 in order to obtain the value of r that will provide the maximum volume. So ito yung mangyayari. This will be dv over dr equals the derivative of this expression will be the constant value. And then minus differentiating this one, it will become 3 pi r squared. And then let's set this to 0. And then let's solve for r, which will provide us with the maximum volume. And so let's just use our calculators. Let's type this equation. 0 equals 115 over 2 minus 3 pi. And then yung x is yung unknown natin. So let's press alpha and then x. And then that's squared. Now press shift solve in order to solve for the value of x. And so now, yung value of the radius that will provide us with the maximum volume is 2.47. So our r will be 2.47. Now let's substitute this back dito sa equation natin. So yung r natin, papalitan natin ng 2.47. I'll just store this dito sa a. And so yung equation natin will be pi times yung 2.47 nakastore sa a. And so a squared times 115 over 2 pi times a minus a. And so yung maximum volume natin is 94.68. The unit is m cubed kasi volume. And so this will be our answer.